Hey guys, we're back. This week's video is a little bit different. We've designed a new and improved bearing. Now it's a print in place bearing, so there's no assembly, and the print bed setup is laid on its side. So what we're going to do instead is go through several iterations in design and the printed prototypes that we evaluated and kind of take you through the process of designing a better bearing. We started exploring bearings with this one. This is a roller bearing. It has a bunch of cylindrical rollers, and they're stuck inside between the inner race and the outer race. We have to use these cone shapes to keep the thing from coming apart so that you couldn't pull the whole thing apart and just have a bunch of rollers on the floor. So this was the first design that actually worked. As these get really short, they tumble in here. They don't roll. They just spin every which way and they bind. You get a lot of things that don't work or they blow apart really quickly. So we found that we had to stretch the length out. There's a ratio of length of the roller to diameter of the roller, and then how closely you can stick them together without them sticking together. You've got to leave a gap, and you want it to be as small as possible. We are running into the problem, we don't have a retainer to keep these rolling elements from touching. So basically when this thing's rolling, all of these are going in the same direction. But because the one in the front, it rolls down in the front, but it rolls up in the back. So when these make contact, this one's going up and this one's going down and they hit, and that slows you down. We scaled this one down, and this is what we used in the winter catapult. And a lot of people had real trouble printing it with the super small rolling elements. And as a result, we've gone back to the drawing board in an attempt to make a better, more robust bearing. It's easier to print. Here's the first one. I'll print it out in yellow. Big, chunky followers in there. What you learned as you print them out is they can do a lot more of this than you realize in the computer. So it's not perfectly controlled, but they're fairly orderly, and this spins really well. It's also a lot bigger than the others, so it spins deceivingly well. We scaled it down, so this is a very tiny version. You can see them next to each other. This is much thicker than the winter catapult, but it is the size of the rollers. So we proved that this worked okay, and then thinned it out. So this is the same thing, but not as thick. And these kind of can get crooked, but they were okay, and we figured it was going to stay in plane all the time and that it was going to be all right. So we printed a bunch of these, various test prints at various phases throughout the design process, and they worked, and we launched them. We moved the conical feature. Instead of being an overhang on the inner and outer race, we made it an overhang on the roller itself. Moved it to the outside in hopes that this would work better. We thought that the larger contact area on the build plate might really help with printing, and it would still retain because it still has an interference here where it holds itself together. This didn't work great either. They tend to layer and they can get crooked. It's possible to make this design work, but it was not behaving really nicely at the scales we needed. We needed to go smaller, not bigger, and it needed to get bigger to be tamed. So these are the hourglass shape rollers, and if you get them in the right spot, they'll roll, but they were never correct. And they tend to stack up. The heads will layer, and because they had so much space between them, there's this giant gap between the rollers that you can get to. They don't stay equally spaced in the real world. That's only in the computer. So we made some attempts to space them with correct head size, but you were losing the contact area that you wanted. It basically was going down the wrong road. The answer wasn't there. It needed to get bigger and needed a new idea. So these were a couple more looks at these little rollers. They seemed encouraging. You can get them to spin, but they're by no means error-proof. They get stuck really easily, and they just have too much free play. So we came up with this guy. Now, this is our latest bearing design, and this thing seems to work really well. We went with a notch in the middle, so we still get the overhang, interlocking feature here, but we have a rib coming out of the inner race and a rib coming out of the outer race, and it keeps the rolling elements centered. Now we get full length of a roller, and we kind of get to ignore the fact that there's a notch in the middle as far as stability goes. And then we packed them as tightly together as we could, and we have them coming off the build plate and just rolling nice and freely. Next step is to scale these up and down and make sure that they're going to work everywhere. But the plan is to start to use these bearings in places where we need bearings, and the hope is that we've solved the problem that some people were struggling to print it, and everybody can print them easily, and we can all enjoy the pleasure of bearings in our assemblies. We landed on this one, and this is the one with the groove in the middle. And this thing is, there's no way to get them to stack up. They're nice and long. We get to use the full length of the roller. We do still need to figure out a way to keep them separate, but the rollers stay captured very well. They do what they're supposed to. And we believe we'll be able to scale this down and still be able to print it with fairly large features to stick to the build plate. And hopefully we'll have fewer problems with them, and we can use bearings everywhere.